Hello and welcome to this Formlabs webinar. This is a shortened version of the original broadcast. If you'd like to view the content in full, please click on the link below.
Welcome everyone, and thanks for joining us today. We're going to discuss about how to produce silicone parts with 3D printed tools. All right, so my name is Juliette Combe. I am an application engineer in the product team at Formlabs, and I conduct research on how to use 3D printing for manufacturing application. So that's going to be me opening the discussion today, and I will be followed by another speaker, Annalisa. I will let her introduce herself.
Hi, everyone. My name is Annalisa Russo. I work in marketing partnerships and on customer collaboration here at Formlabs. My personal background is in material science, so it's been really exciting to tackle this topic. I'm really looking forward to sharing customer insights with everybody.
Perfect. All right, so we can start the agenda for today. I will first give a little intro on silicone and manufacturing process for shaping silicone, and then discuss how to do 3D printed rapid tooling. And then Annalisa will take over and give a lot of recommendation and guidelines on how to actually do the workflow, selecting a mold type, step-by-step workflow and best practices, and also share some user stories. And as I mentioned, we're going to have a Q&A session at the end. Just give a little context. So silicones are a class of polymers that contain the element silicone and oxygen, and they transform from a gel or a liquid to a highly flexible and stretchable solid after what we could call a curing process. So they are very popular material because they are very versatile. They have high performance property. Many of them actually. So first, they are soft ergonomic geometry, but they also have very good heat resistance, electrical insulation, chemical stability, high tear strength as well, and watertight seals and so on. So they are very popular across many industries, from automotive to construction, electronics, consumer goods. So you can see those pictures on these slides. In the healthcare market also. If you want to share from what industry you are, feel free to discuss that in the chat. Would be very curious to know what are the industry that you are in. And also in the entertainment industry, this is pretty popular material as well. So just quick slides on Durometer scale. That is a standard for showing the different hardness of silicone. So we're going to talk about a few different silicone here. You can see it ranges from a very soft material to very hard material, from soft mouths to harder parts. So silicone elastomer dominate the market. This is what we are considering today. This is our focus, and they can be divided into three categories. First, liquid silicone rubbers, that is also called LSR. Those one are high performance silicone, and they are usually employed for producing technical parts with very tight tolerance, and they are processed at high temperature with what we call liquid injection molding. So they are usually selected for large volume production and industrial applications. So you can see it on the left here. Another type of silicone are high temperature vulcanized or HTV silicones. They're also called sometimes heat cured rubber, HCR. Those one are more solid silicone usually, and they are also having a lot of great properties in terms of temperature resistance, aging as well. So they are often used in cables and insulators. And usually they are processed with a lot of different methods, actually, manufacturing process, but very often extrusion or compression molding, among many others. So you can see it on the right. And a third type of silicone elastomer is room temperature vulcanized silicone, RTV. this is what we're going to focus on today. This is basically silicone that are cured at room temperature, so there's no high heat involved. So they are relatively easier to process from the two previous silicone types, and still have great mechanical property and thermal property as well. They are very popular in various industries to make gasket, medical device, overmolded device as well. I saw that a lot of people were interested in overmolded device. And also very common to use mold making, to make mold, sorry. So usually they require much longer cycle time to process and more manual labor, so they are better suited for small volume production. And they are processed also by injection molding or compression molding, different type of molding processes. And in those type of RTV silicone, we actually consider three types: platinum catalyzed silicone that are higher cost, but also superior in terms of long-term dimensional stability and low shrinkage. Then there's tin catalyzed silicone. Those have lower cost, but are less stable over time and tend to have higher shrinkage rate. And then there's also silicone putty, which is a two-part putty in which the components is blended together in equal volume. And those ones are have also similar different type of hardness. So I just want to mention here that I know platinum catalyzed silicone are quite popular and also have concern for reacting with 3D printed molds. So we're gonna discuss that later in the presentation, and Anisa is gonna discuss that later on. All right, so now I want to discuss 3D printed rapid tooling. We actually already have a lot of content on rapid tooling in general. This is a popular topic for manufacturing process. And so if you're interested to learn more about what is rapid tooling, we have a page on our website, and we also have a white paper about that. So this is an interesting resource to understand what is rapid tooling. But I'm just going to recap here what it is. So as I mentioned before, common silicone processing technique can be injection molding, compression molding, extrusion, resin transfer molding as well. So you can see here those illustration of this process. So those are traditional process that involve some sort of tooling. So either a mold or a die that will shape the silicone into the shape that you want for your parts. And usually this tooling is made out of machining metal. And it can be very expensive to produce, and it can take weeks of lead time to produce. So most of those techniques are industrial techniques that are used in mass production, and the tooling is not really easily, you cannot make a lot of modification on your tooling, on your mold of the die. So for prototyping, for designers that would like to prototype silicone parts, or that would like to make small series of silicone parts with the right silicone that they're going to use for production, it's actually very challenging to be able to do that with those common manufacturing techniques. So if you look at the graph of product development process, here you can see that it starts with ID, concept, all the way on the left, and then series of prototype, first series, and pre-production going to mass production. So in mass production, usually we're using traditional manufacturing method that I just mentioned. And for early concept and first prototype, usually prototypers use direct 3D printing. And what we see is that there is a gap between prototyping and production. And this is where rapid tooling enters. It's the process of 3D printed tool rapidly for low volume to be able to produce prototypes and small series, and also just either a series of prototype or just the prototype in the material that you want. So RTV silicones are great for prototyping silicone parts, and you can actually do it with very limited material in-house with very accessible type of silicone as well. All right, so now, as I introduce what is rapid tooling, I just want to give a bit of context why 3D printing is actually enabling rapid tooling. So for those who don't know Formlabs, we are a manufacturer of professional solution for 3D printing. So we manufacture the hardware, the 3D printing resin, and also the software. And 3D printing is really a powerful tool to produce parts in limited quantity and to produce tool rapidly. It's because it's a tool-less fabrication process. So you get flexibility and agility to change your design. You also have design freedom, so you can have molds that have also different type of complexity. And so at Formlabs, we have two 3D printing technology. The one we recommend for molding will be SLA, for silicone molding. So that stands for stereolithography. You can see here is a picture of the Form-3 printer. It's a resin-based process. And those printers are very easy to implement, operate, maintain, and come with a complete ecosystem. So this is really accessible to just set up in your prototyping lab. It requires very limited equipment that you can save time from your CNC machine or any other method that you were using to produce your mold. And SLA, so stereolithography, produce very high resolution and accuracy part with clear details. So it's usually the one we recommend for molding, and most of our users are interested in this because it has very smooth surface finish and detail print. That's the main characteristics for SLA, and we also see that SLA is very stable, produce very stable prints that are isotropic, and we also developed portfolio of different type of resin that have different performance. Some resin are clear, so they actually is one of the one that is used the most for silicone molding, and that is, as I mentioned, very smooth and transfer all the details of the design into your parts. All right, so that was it for the intro. Now I'm going to leave the floor to Annalisa, and she's going to guide you through the workflow and recommendation for making silicone parts. Sorry.
Okay. Thank you, Julia. You can skip ahead to the next slide because I'd like to show a table here. So 3D printed tooling using SLA 3D printing really opens the door to a few different types of mold configurations for forming silicone parts. And the type that you choose is really going to depend on a few different factors. That includes your target part geometry, the type of silicone that you want to use, and then also how many copies of your part you want to make. So these tooling types could either enable you to use the same mold dozens of times, or we'll go over a sacrificial type of mold called an eggshell mold, which is only used once. So the first type that's shown here is compression molding. In this particular mold type, you're squeezing a fast curing silicone putty into a two-part mold using a clamp. One thing to note is that, of course, it's always important to do draft analysis on a mold design. This particular type of mold is not very friendly to undercuts or sharp angles. So it's really important to consider how those mold bodies go together and come apart during compression. This mold can be used dozens of times before it fails. The second mold type we'll cover is injection filled molds, which are used with a two-part liquid silicone. So in this type of mold style, you're injecting liquid silicone through an inlet and then allowing it to release through air vents. When it comes to prototyping or maybe for short run production, a really common configuration for this is to use gravity to assist the filling process. And that's actually what's shown in the animation here. So basically you're filling or injecting the silicone through a port in the top of the mold. That silicone snakes around to the bottom of the mold cavity. And then you have air vents again at the top of the mold.
Thank you for tuning in to this webinar preview from Formlabs. To view the content in full, please click on the link below. Alternatively, if you'd like to get more information on our products and services, then please visit our website.